Chain drive. A solution to prevent slipping that may occur in belt and rope drives. In this lecture, we will cover chain and its types, caudal action and its effect on velocity ratio, equation for length of chain.
Let us first understand a chain drive and its components. A chain drive primarily consists of a driving sprocket, a driven sprocket, and a chain, which is a set of links. What are sprockets? Sprockets are wheels with projecting teeth around the periphery that can fit into the corresponding recesses in the links of the chain. They resemble spur gears. What are chains? Chains are a set of rigid links which are hinged together. It allows them to wrap around the driving and driven sprockets. They are mostly used to transmit motion and power from one shaft to another, when the distance between the centers of the shafts is short, such as in bicycles, motorcycles, agricultural machinery, road rollers, etc. Let us now understand how chains are classified on the basis of their use.
The chains, on the basis of their use, are classified into the three groups: 1. Hoisting and hauling chains, 2. Conveyor chains, and 3. Power transmitting chains. Hoisting and hauling chains. These chains are used for hoisting and hauling purposes. These chains may have links of oval shape or square shape. Chain with oval links are used only at low speeds, such as in chain hoists and in anchors for marine works. Chain with square links are used in hoists, cranes and dredges. The manufacturing cost of square link chain is less than that of chain with oval links, but in these chains, the kinking occurs easily on overloading.
Conveyor chains. These chains are used for elevating and conveying the materials continuously. They generally operate at slow speeds of about 3 to 12 km per hour. The conveyor chains are of the following two types. 1. Detachable or hook joint type chain, as shown in the top figure, and 2. Closed joint type chain, as shown in the bottom figure.
Power transmitting chains. These chains are used for transmission of power. They are generally of three types. The first figure depicts a block chain, also known as bush chain. These types of chains were used in the early stages of development, in power transmission. It produces noise when approaching or leaving the sprocket teeth, because of rubbing between the teeth and the links. The second figure depicts a bush roller chain. It consists of outer plates or pin link plates, inner plates or roller link plates, pins, bushes and rollers. A pin passes through the bush, and is secured, in the holes of the roller, between the two sides of the chain. The rollers are free to rotate on the bush. It protects the sprocket wheel teeth against wear. A bush roller chain is extremely strong and simple in construction, and provides good service. There is a little noise with this chain, and may be used even when the lubrication is little. However, elongation of links due to wear, and stretching of the parts, leads to unequal distribution of load on the sprocket teeth. This aggravates the wear of the roller surfaces and of the sprocket wheel teeth. The third figure depicts an inverted tooth, or silent chain. This chain is designed to eliminate the evil effects caused by stretching, and also to operate noiselessly. When properly lubricated, this chain gives durable service, and runs very smoothly and quietly.
Have you heard of the term pitch and pitch circle diameter? Well, we will now move on to understanding these terms. Pitch of the chain. It is the distance between the hinged center of a link and the corresponding hinge center of the adjacent link, as indicated. It is usually denoted by P. Pitch circle diameter of the chain sprocket. Consider a chain that is wrapped around a sprocket, as shown in figure. The points A, B, C etc. are the hinge centers, or the roller centers of the chain. The circle drawn through these centers is called pitch circle. Its diameter is known as pitch circle diameter.
Hey, hi! So now let us derive the relation between pitch and the pitch circle diameter. Consider a chain that is wrapped around a sprocket. Let A and B be the hinge centers or the roller centers of the rollers that make up the chain. Let us join point A and B. Let AB subtend an angle gamma at the center O. Now from O, let us drop a perpendicular OC to this line AB. If this complete angle is gamma, then this half angle over here will be gamma by 2. Pitch is nothing but the distance between two roller centers, or the distance between two adjacent roller centers. So pitch is equal to AB. Here it is very clear to us that AB is twice of AC. So substituting AB by 2 times AC. Now in this triangle ACO, angle ACO is 90 degree, AO is the hypotenuse. Therefore AC will be AO sine gamma by 2. Now AO is the radius. Therefore 2 times AO will be diameter. So substituting 2AO or replacing 2AO by diameter D. Now rearranging the terms, we can express this equation between pitch and diameter as diameter is equal to P, that is pitch, into cosec gamma by 2. Now let us find the value of gamma. Gamma is nothing but the angle that the line that joins the hinge centers or the roller centers of two rollers that it makes at the center O. Therefore it is very clear to us from this construction or from this geometry that angle gamma will be equal to this complete circle angle, that is 360 degree, divided by the total number of teeth that are there on the sprocket. Therefore gamma is equal to 360 degree by T. Substituting this value of gamma in the equation for D, that is replacing this gamma over here by 360 by T, we get diameter of the sprocket D is equal to pitch P into cosec 180 degree by the number of teeth T.
Velocity ratio. Velocity ratio is the ratio of the driving sprocket to that of the driven sprocket. That is VR equal to N1 upon N2, which is equal to T2 upon T1, where N1 is the speed of rotation of the driving sprocket in RPM. N2 is the speed of rotation of the driven sprocket in RPM. T1 is the number of teeth on the driving sprocket. T2 is the number of teeth on the driven sprocket.
Hi friends, welcome back. Let us now understand the polygonal effect or the caudal action. Now, polygonal effect or the caudal action is, we observe that the linear velocity of a chain is never constant during motion. It keeps on varying between a minimum value and a maximum value. Let us understand why this happens. Now let's consider a hypothetical case wherein a sprocket has only 4 teeth and this chain is wrapped around that particular sprocket. A, B, C, D are the roller centers of the rollers that are present on the chain. Now let us calculate the velocity of the chain. we always know linear velocity will be equal to distance of the chain from the hinge center, that is radius, into the angular velocity of rotation of the sprocket. If the sprocket is rotating with an angular velocity omega, at this current instant we find this chain is at a distance of OB from the center O. Therefore, linear velocity of the chain will be omega into OB. Now let us consider a second instant wherein the sprocket has turned by an angle gamma by 2. Please note this distance over here will be OB cos gamma by 2, since in this right angle triangle this angle will be gamma by 2, OB is the hypotenuse, therefore this distance, which is the adjacent side to the angle, will be OB cos gamma by 2. Now here the linear velocity of the chain will again be the distance of the chain from the hinge center, that is this distance into angular velocity of the chain. So the current or the new linear velocity of the chain will be angular velocity of the chain omega into this distance, which is OB cos gamma by 2. So you see, even though the sprocket is rotating with the same constant angular velocity omega in both the cases, but the distance of the chain in each cases from the center is different. Here the chain is at a distance OB itself from the center, but here the distance of the chain from the center O has reduced and is now OB cos gamma by 2. Therefore, we see in the first case the velocity of the chain was higher, while in the second case, because of this new term cos gamma by 2, the velocity of the chain has decreased. For all positions of the chain, its value or its velocity will be varying according to this angle, according to the cosine of the angle. So at one instant it will have a maximum velocity, after some instant it will have a minimum velocity, or we can say the velocity of the chain will keep on alternating between a maximum value and a minimum value. So such effect is called as polygonal effect. This effect of the chain makes a chain useless in cases where precise velocity of the outer shaft is required. So now let us move on. Oh, I forgot something. Okay, so now let us, to calculate speed variation, we know speed variation would be the difference between these speeds divided by the original speed, and it is found that if the number of teeth is 11, then the variation in speed is 4%. If the number of teeth on the sprocket is 17, then the speed variation is 1.6%. If the number of teeth on the sprocket is 24, then the speed variation is 1%. It is very clear to us that as the number of teeth on the sprocket goes on increasing, the speed variation of the output shaft goes on decreasing. So now let us move on to the next topic.
Advantages of chain drives. Gear drives can be used for transmitting power only over short center distances. However, chain drives can transmit power over a relatively wider range. Shafts can be driven in the same or opposite direction by means of a chain from a single driving sprocket. A chain drive has the ability of transmitting motion to several shafts by one chain only. Chains are made of metal, therefore, they occupy less space in width than a belt or rope drive. Chains do not require initial tension, hence, the forces acting on the shafts are reduced. A chain drive does not slip. A chain drive provides a high transmission efficiency, up to 98%. Years of service can elongate chain links, thus increasing the chain length. However, the increased length can be corrected by removing links from the chain. Chains are therefore easy to replace and repair. Atmospheric conditions and temperatures do not affect the performance of chain drives. They do not possess any fire hazard.
Disadvantages of chain drives. Wear at joints increase chain pitch. This increases the chain length. Chain may therefore leave the sprocket, if tension is not adjusted from time to time. Chain drive therefore needs accurate mounting and careful maintenance. Bevel gears and quarter-turn belt drives can be used for non-parallel shafts, but not chains. The caudal effect leads to non-uniform rotation of the driven shaft. It makes a chain unsuitable for applications where precise motion is required. They generate noise during motion.
Hi, welcome back. Let us now derive the equation for the length of chain. Consider two sprockets. Let O1 be the center of the largest sprocket, O2 be the center of the smallest sprocket. The center distance between O1 and O2, let it be x, and let the radius of the largest sprocket be R1 and radius of the smallest sprocket be R2. Then we know the length of a belt that is wrapped around this sprocket would have been pi R1 plus R2 plus 2x plus R1 minus R2 the whole square by x. But since chain is made up of links which are rigid, which cannot wrap around the circumferences, therefore the length of a chain would actually be smaller than the corresponding length of the belt. So we will now need to modify this equation for the length of the belt to calculate the length of a chain. Therefore, for this particular equation, let us now concentrate on this part, that is pi R1 plus R2. Pi times R1 plus R2 is actually the length of this, is actually the half circumference of the largest sprocket plus half circumference of the smallest sprocket as indicated by the red arcs. Replacing this length equation by a corresponding equation for chain, then we can write pi times R1 plus R2 will be approximately equal to pitch into T1 plus T2 by T. Please note these terms are not equal, these are just corresponding equations, where pi times R1 plus R2 is actually this complete distance as indicated by the red arc, and P times T1 plus T2 is this distance of the cords that is wrapped around the sprockets. So this was the equation for the length of a belt. In this equation, we are making some substitutions. That is, this term pi times R1 plus R2 is being replaced by pitch T1 plus T2 as we had seen in the earlier pitch. We know the relation between the diameter, the radius and the pitch of a chain. So substituting R1 and R2 respectively with these terms. Here in this equation, so pi R1 plus R2 is replaced by P times T1 plus T2 by T. Again R1 and R2 are substituted by this and these terms respectively. So we get this equation. Now from this equation, let us take pitch outside. So therefore here this would be x by p. Here again it would be x by p. And this pitch are all commonly taken out. Now let us substitute x by p with a term m, and also over here let us take 1 by 2 common from this term and from this term outside the bracket. Please note this is in a square bracket, so when it comes out it would be 1 by 4. I am taking this 4 to the denominator, so it would be 4 over here, and replacing x by p with a new term m, then I can write L is equal to p into this complete term in the bracket. I can now write length of a chain is equal to pitch p into k. Now let us understand what is k. Now length of a chain will always be expressed as pitch into the number of links that are present in the chain. So with that analogy, k is nothing but the number of links that are present in the chain. Now the number of links in a chain will always be an integer. That is, we cannot have a chain with 66.1 link or a chain with 66.2 links. It will always be 61 or 62 or 66 or 65. That is an integer number of links. So please note, in sums, whenever the value of k comes out to be in decimal, you need to round it up to the next integer. Then multiplying that value of k with the pitch, that is multiplying the number of links with pitch we will be getting the complete length of the chain. Problem for practice. Here a chain drive is used for reduction of speed from 250 rpm to 120 rpm. So this is N1, that is the speed of the driving sprocket. N2 is the speed of the driven sprocket, that is 120 rpm. The number of teeth on the driving sprocket is 20, that is T1 is given to you. So you have N1, you have T1, you have N2. We now need to find the number of teeth on the driven sprocket. We know number of teeth on this driven sprocket, N1 T1 is equal to N2 T2. Since N1 N2 T1 is known, we can directly find T2. Now this sum has another part. Here the pitch circle diameter of the driven sprocket is given to be 600 mm and the center to center distance between the two sprockets is 800 mm. Then we need to determine the pitch and the length of the chain. We already have derived the equation for the length of the chain. So recalling that equation, or before that, let us calculate the pitch of the chain. Pitch of the chain, we know the equation between the diameter of the sprocket and the pitch of a chain. So since the diameter of the driven sprocket is given, that is 600 mm, so d2 will be pitch p into cosec into 180 by t2. Since this is diameter of the driven sprocket, the number of teeth over here should also be for the driven sprocket. If diameter was for the driving sprocket, then the number of teeth should have been for the driving sprocket. So if this was d1, this would be t1. If this is t2, d2, then this is t2. Substituting all values over here, we will be getting pitch. Now length of the chain we know is equal to pitch into number of links k. Equation for number of links k is given over here. T1, T2, T2 is calculated over here. So T1, T2, M over here, M we know M is nothing but the ratio between the center to center distance x and the pitch of the chain p. Therefore M will be equal to x upon p. Substituting the value of M over here and all other parameters, we will be able to get k. Please do not forget to round up the value of k to the next integer if it is in a decimal form. So once we have k and once we have p, then we can find the value of the length of chain. For your reference, when you solve this sum at home, please see to it that the answers that you get matches with these answers, where the number of teeth on the driven sprocket is 40, pitch is 47.1, the center to center distance is 16.98, the number of links is 64.5, that is 65, and the total length of the chain is 3.06 meters. Thank you.